Hi, I'm Elizabeth with the C++ group, and this video is brought to you by the C Monster Defense Initiative, which includes me, Daniel, and Ethan. Let's get to the backstory of our project. Noe sent a letter or audio message in encoded language to her best friend Kate, who's traveling overseas. While the message is being sent, a sea monster gets a hold of it and adds his own noise to it. Kate, who's experienced in solving encrypted messages, knows how to untwist the letter. As said before, my name is Elizabeth, and as the team leader, I worked on setting up the meetings and getting in contact with the other team members. In addition to coding, I also played a key role in designing the team's slides and the logo you see in the bottom left corner.
Hi, my name is Daniel. I worked on most of the preparation work, including generating the message and encrypting it. I also conducted tests for the code.
Hi, I'm Ethan. I worked on the decoding and twisting of the message. We used a machine learning model, MLP, for this purpose. I trained the model and used it for decoding. Although it was easy to encrypt and twist the message, untwisting it was the hard part. The first challenge was that the twisting algorithm is unknown. During the untwisting part, we must assume that we are K and do not know the twisting algorithm. This makes it much harder to decode. What's worse, we don't know the noise. It's impossible to create some equation that satisfies all noises. The last challenge is that C++ isn't very efficient for solving machine learning problems. For example, Python has an MLP classifier class that can help train the model. On the other hand, C++ doesn't have a built-in class for this.
Side note, what is a linear regression model? Given many training examples with features x1 to xm and expected result y, find w0 to wm so that w0 plus w1 times x1 all the way to wm times xm is as close to y as possible for each example. The algorithm used is gradient descent, which involves defining an error function and trying to minimize it iteratively.
Although we were getting closer to the solution, there were still a couple issues. For example, when we tried to use the weights to regenerate the original message, we were ending up with very wonky results. We also had to do some experimenting and fine-tuning to get things right. Also, there was some dispute as to the indexing used to run the gradient descent. Finally, making the code work with an actual string message was also a bit tedious.
As said before, the basis of our code was a 5-feature linear regression model. In our code, we used gradient descent to regenerate the optimal weights. We also tried experimenting with different ideas and strayed from the example our supervisor gave us. After a couple of weeks, we realized that we could change the initial value of the weights to get a better result. We also found an error in the error computation. And just like that, we were one step closer to achieving our goal. Now, Ethan's gonna show us a demo of the code we made.
Okay, so this is the code we made, and I'm going to demo it as Elizabeth said. So suppose I enter a message, say C Monster Defense Initiative. You can see here that the encrypted code is full of -3s and -1s and 1s and 3s. So this is basically the encrypted code, and then on the bottom here you can see the twisted code. You can see that after adding the noise and twisting it, it looks very weird because and there and you can really tell that there is no pattern going with this. This is the untwisted code, and it's basically the encrypted code with one difference. The encrypted code has 4 -3s. We actually the point of -3 is actually we don't need -3s. We can use any number, but the point is that the first four the first four numbers will be deleted in the untwist through the untwisting process. You can see that from -1, -1, -3, and 3. You can see here that it's the same for the first four and for the others too. In the And we got the final message as Sea Monster Defense Initiative, which is what I entered here. Thank you.
Thank you.
Thank you.